Hi everyone. Today we'll be talking about accuracy and precision when it comes to measurement, as well as percent error in verifying our results. Accuracy and precision help us determine how reliable our measurements are. Accuracy refers to how close the measured value is to the actual value, and we find this with the mean or the average. So in math, the mean means you're adding up all of your values and then you divide by the number of values. Precision refers to how close our measurements are to one another. So we do this by finding the range. And in math, the range is taking the biggest number and subtracting that by the smallest number. When we have a smaller range, that means that we are more precise because our values are very close to each other. When we have a large range, it means that our data is pretty scattered and they're not very consistent with one another. So we're going to do some examples together and determine which of these students was the most accurate and which was the most precise. So with accuracy, again, we're going to be looking for how close they are to the true value, and we're going to find the average and see which of the average is closest to the actual value. And then with precision, we're going to find the range and see which is the smallest number that those data points are going to be the most precise. So here we have 3 students who repeatedly weighed a lead block known to have a mass of 10 grams. So the actual value in this case is the 10 grams. We want to see who was closest to this mass. Okay, so student A has 4 trials rather, and the average of these trials is 10.13. Student B had also 4 trials, their average was 9.79, and student C had 4 trials and their average was 10.01. So in looking at these 3 students, we can see that student C was the most accurate, okay, because they are closest to 10.00 grams, okay. For precision, we're going to take the largest value for each trial minus the smallest value. So in student A's case, we would do the 10.49 minus the 9.79, and that gives us 0.7 grams. For student B, we would take the highest value, which is 9.82, minus the smallest value, which is 9.75, and we get a difference of 0.07 grams. And finally, for student C, we would take the largest value in the trial, which is 10.03, and the smallest value, which is 9.98, and that difference is 0.05. So with this case, student C is both accurate and precise, okay? So remember, to find the average, you add up all the trials, so N1 plus N2, so N1 plus N2 plus N3 plus N4 divided by 4. So another way to determine if our experimental results are close to the accepted value or the true value, we can do a quick percent error calculation. And percent error is just the difference between the experimental value and the accepted value as a percentage. So to do that, we're going to take the experimental value, which is represented as E here, minus the accepted value, which is the true or actual value, divided by the accepted value, and then that amount times 100. You'll also notice those two bars on the side of the equations. Those refer to something called absolute value. So with absolute value bars, you would take the positive value. So for example, if this gave us a negative number, we would take the positive number and then multiply that by 100. So let's do an example. So there are 34 questions on a test. John only answered 22 of them correctly. What is the percent error? So in this case, the 34 questions would be the accepted or true value, because this is what ideally he would have done perfectly on. He would have answered all 34 questions correctly. However, he only answered 22 of them correctly. So that's what he did in the experiment, or that's what he performed. So his experimental value would be 22. So to do the calculation, we're going to do 22 minus 34 divided by 34 times 100. Now, 22 minus 34 is obviously going to give us a negative value, but remember, because of absolute value, we're going to just take the positive amount. So in this case, John had a 35% error. Next example says, the label says a rope is 2.15 feet long. John measures the rope as 1.85 feet. What is the percent error? So what John measures is his experimental value. So this would be 1.85. The true value of the rope is 2.15 feet. So we're going to do the experimental value minus the accepted value divided by the accepted value times 100. And we get 32.6%. So the percentage here is how far off they were. That is their percent error. So John has 35% error, and in the second experiment, he measured the rope a little bit off, and he was 32.6% off. So this shows us how far off we were from what we really wanted.